My name is Teemu Turunen-Saaresti. I'm a professor of fluid mechanics here in LUT University, working on, let's say, rotating machines in turbomachinery specifically.
Yeah, I'm Jussi Sopanen. I'm professor in machine dynamics in mechanical engineering, and my field of research is dynamics and vibration, and mainly rotor dynamics.
I'm Juha Pyrrhönen, professor of electrical machines and drives, and we have a common shaft. He is on the other end of the shaft. I try to make electromagnetic torque in between, and Jussi spoils the feeling because nothing works when we start discussing about the
Trying to combine these two things in a working machine. Yeah, I would say that it's very important, this industry-academia collaboration, so there comes good research topics there from industry, and it's like topics which have a relevance.
Yeah, and I also see that we are making a research in technology, so we need the industrial cooperation, discussion together with the industry to see that, okay, when we have the ideas and we have the research, that how it can be applied, or could it be applied in the industrial applications? So I find.
But when in electrical engineering department 20 years ago with Professor Jarmo Partanen, we were thinking that if there is a question that is it clever to work with the industry or not, our choice was clearly that it's better to work with the industry than don't work at all, because the financing is such an issue that we need the industrial financing.
What is evolved in these, let's say, 20 years, what I have been here, is that we have been, now we work maybe more, let's say, scientific topics with the industry than otherwise. It was more engineering previously, now it's more, let's say, complicated and scientific issues. So we are working together with high temperature heat pumps, and that's associated on turbomachinery. Of course, you need compressors in that kind of cycle. So there is a cooperation with the research, let's say, research project, and then of course also some, let's say, thesis topics.
Rotor dynamics of and development of high-speed electrical machines, that has been one of the collaboration field lately. So and we have had over the years many projects regarding that, and it's nice to see that also some of those projects have led to commercial products which are now operating in the field.
The Switch wants to make the business, and we should be capable of helping the company from the scientific point of view, so that the result is sound from both the commercial and scientific point of view.
What we kind of provide is probably more insights on some of the phenomena occurring, and then the Switch is the one which kind of take it into action in the real machines or real, let's say, electric motors. So
I think that the Switch would not exist in Lappeenranta without this university.
Yeah, definitely this educational aspect is important, because while we are doing the research, we are simultaneously educating new talents, and those talents then often, well, some continue in academia, some will go to industry. But also I would like to say that these research problems and challenges which are there, they are often coming from industry. We get good research topics also. Of course, we have some own research topics, but both ways it works.
Well, from engineering point of view, at least maybe I'm too practically oriented, but I like the ideas which are really brought into the industry.
This what we are doing, this research is very multidisciplinary in nature, and I think that that's one of our strengths, that we can cope with those multidisciplinary problems.
I think, of course, we benefit for having able to make the research in interesting topics, And I think the industry, of course, benefits getting the skilled people from the university, doctors and masters, and then, of course, getting the results which they can employ or deploy in their work. So
I could take one this recent press release that Rantec had installed new magnetic bearing supported blower into paper factory. Was it in Turkey? So that work started maybe 5 years ago. Now after some years it is a commercial product which is running in the factory. So that's a good example of how research yields commercial products.
I was participating the very first steps of your company, and then we started with a 10,000 RPM, was it 120 kilowatt machine, and we were thinking that this is something great. Well, nowadays you have developed it during generations, and now it's a, let's say, a real product. Those days it was almost a hobby. Well, this heat pump question is of course one of those, because it's related to high-speed technology. LUT is famous for its high-speed technology research, which has started in 1980s, close to 50 years, and there are always emerge new fields where high speed can be applied, and if we consider this vacuum compressor, which was just mentioned, it is quite similar to make also a high pressure compressor, which can be used for heat pumps. And it seems to be so that everybody is now interested in replacing burning heating power plants with heat pumps. And well, that helps in mitigating the problems related to too much carbon dioxide in the atmosphere.
yeah, I would also see that the near future, heat pumps are coming, especially high temperature, high powers. Maybe even more in future, the hydrogen compression will be also the issue. We are now discussing on that we should produce green hydrogen. It should be distributed and stored, and we need the compressors, especially high-speed compressor, very high-speed compressors for that application. So that will be also, in my opinion, one of the applications in the future.
Interesting research topics and challenging multidisciplinary research.
Yeah, I would also expect that we have more deepened collaborations, so more discussions and then more results.
It's easier to collaborate.
Yes.
And
Yeah.
very many fields of engineering are so complicated that without collaboration you are in trouble.
I think we can do more complicated, let's say, topics and research on them when we have a collaboration. We can do actually some real, let's say, prototypes and real test units here when we collaborate.
Yeah, and this multidisciplinary is important to understand for students and researchers, so that they are not thinking that, okay, it's about one field, differential equations which solve the problem, because it's much wider, and they should understand this wider scope of problem.
Yeah, well, I think the future is, let's say, bright in a way that we have said that we want to electrify the heating and also the process, let's say, steam in industry, and heat pumps are a very efficient way of doing that. And that's why I will see that there will be more and more these heat pumps in industry and also in, let's say, households and let's say in the cities working on. So a lot of new businesses and opportunities there.
Well, hopefully you succeed somehow in penetrating the market and creating us new problems in the development of the of the high temperature heat pumps.
Yeah, I would also see that the role of these companies like Switch is then to bring the technology to the market. So that's not what we are doing. We are making the testing or maybe protos, but putting this technology on the market, that's the company's business.
Active magnetic bearing, high-speed motors, and Teemu is studying the fluid machines.
Compressors, of course, heat exchangers, the whole cycle itself, working fluids, what we are studying, because in future we are not going to use these synthetic fluids which are harmful for environment. We will use, let's say, carbon dioxide or some hydrocarbons, and more research is needed for that. So we like challenges, and especially in the rotating machinery, then we need more speed, and that's what we like to have. Well, yeah, basically the refrigerants what we are working on is the carbon dioxide, and then hydrocarbons like butane, propane. And well, when we are talking about these working fluids or these natural refrigerants, then the rotational speeds are usually very high. So we are talking tens of thousands of RPMs, and the powers are still megawatt size. So that's a challenge, high power, because that's the requirement, let's say in industry, not anymore like small kilowatt size machines, but megawatt size machines, but those should work with the high rotational speeds of tens of thousands.
Yeah, in high-speed technology we are very often facing the limits of material physics.
Well, basically those comes from the cycle design. So for example, heat pump, you have a certain working fluid like CO2, and then based on its properties and of course how these compressors work, the rotational speed, like optimal rotational speed can be chosen, which is usually high, and then
so it's not just one field optimization, it's multi-field optimization. Yes, it's done. We have recognized that this material question is very important, and we have, for example, internally collaborated with material researchers, and they are developing new materials and technologies and so on.
Yeah, I think that's needed in order to bring the technology also to the next level, because we really see that also the materials are a challenge, and now when we have this INERCOM platform, we have also the guys from material sciences bring in. So
let's say that the basic understanding of high-speed technology applications has been reached somehow, and when we push the limits higher and higher in different directions, we are always then facing the question that can this really be manufactured so that it remains intact in all conditions which are there.
well, I think in our point of view, there is two challenges relating to these high temperature heat pumps and working with the natural working fluids. One, that we are some of the natural refrigerants, we are working in a supercritical state, and that's not well known how the fluid is operating. So we need to do the research on that. The second one is about the design of the compressors. So in certain fluids we will have also very high flow speeds, which means that we have a supersonic flow. So we need to bring up the design of these compressors which can handle that kind of situation. So
yeah, and from a mechanical side, it's high rotation speed, it causes high stresses there, and then it comes at the strength of materials question. And then, of course, higher power, megawatt size power.
Electrical phenomena, they are very fast. So they do not bring any limitations for the speed. But when you start making real machinery, then you will find yourself in difficulties in very many cases. And well, this mechanical engineering is very often limiting. But then, of course, we have losses in the system, and the electrical machine is vulnerable for high temperatures. We can't operate with very high temperatures because we must be capable of maintaining the insulation of the system. And we have been trying to find out ways how to as directly as possible cool the machine to be capable of increasing its specific power and power density. In high-speed applications, the power density is inherently high, and that results typically in difficulties in cooling the machine. It may be also the heat transfer which spoils it.
Well, INERCOM is a multidisciplinary platform, research platform of LUT. So it collects experts from different schools from our university, like engineering. We are from engineering, and then there are material scientists, material physics, business school, and mathematics, and this kind of multidisciplinary collaboration. INERCOM promotes this multidisciplinary collaboration. Basically, the meaning or the benefit of INERCOM is that we can have more resources for preparing, for example, EU projects. Well, it's through these projects like Business Finland Co-Innovation projects or other projects where we collaborate with industry. At the moment we have several projects there where collaborators are, I would say, 10 different companies or something, at least if we count all of those easily. So it's a very good tool on that. This high-speed technology-related research that has been done here at LUT 40 years or something like that, and then definitely we should have some kind of tool or some kind of somehow combine this knowledge what we have and make it bigger.
So it's based on the research which we already done in the past together, and we kind of wanted to expand this people working around this high-speed technology, so get also the material sciences, and the mathematics and the business inside here. And this was a very natural way of doing it, forming the platform.
I think these heat pump studies have brought very many collaborators because there are so many companies interested in the field.
Contact us, any one of us. So.
Yeah.
And if you need to pick one, contact me. I will deliver. But yeah, that's how it goes. So contact, and then we can start discussion and see what we can do on the challenge what company has.